Hello then, welcome to this course on big data processing with Vaex or data analysis with Vaex. My name is Valentine and I'll be your instructor. In this course, we're going to be learning how to use the Vaex library, that's a Python library for data processing. And this library really works well when it comes to where you have lots of data and you need to analyze that data or process that data within one single machine. And that data might be in the scale of 100 gigabytes plus. And what better tool to use than Vaex? And it works really well, especially when we have a single machine. In relation to other tools, we might want to look elsewhere if we have smaller data sets, or if we want to perform data processing in a distributed manner where we are reducing our data into smaller chunks and running them in just different clusters of machines. In such a situation, we can use a tool like Python Dask, or look into how we can use a tool like PySpark that again implements distributed computing. Our focus will be learning how to use this tool. It's quite similar to how we would implement pandas. So you'll get to notice that a lot of the functions that we're going to be using will just be similar to an interface that we're used to. Something else is that this library also provides us with the ability to visualize data, as opposed to a tool like Dask or Polars. There are more functions within the Vaex library that allow us to perform visualization. So let's get started with the practice work. You can visit the description section of this video and click on the sample practice resource link. That should take you to a page that looks like what you're seeing on your screen. Well, you will get to this page later, but you'll get to, first of all, this page. Click on the link, sign up, and then once you have logged in, you will just click on continue learning and you get to the sample notebook. I'll be using the practice notebook, which is just similar to the sample notebook. The only difference is that there are more challenges in the practice notebook, and if you're an Afterwork member, you get access to it. Right, so let's get started. The first thing that you need to do is to install Vaex. We install it using pip install Vaex library, Vaex, and that should install the Vaex library in the environment that we are working in. And once we have done that, the next thing that we would need to do once it has installed, which might take a few seconds, the next thing would be to import the Vaex library, which we import using import Vaex. And that should be it in terms of just the installation and importation process. Now, we have curated examples, code examples that contain just different contexts that will help us to be able to learn how to implement various data analysis techniques using the Vaex library. So with each and every code example, we provided a data set. So you need to download the data sets that we will need. So click on the download links and follow through and just download the zip file that will contain our data set. Our focus will just be to use data that we are able to work with at this particular point in time. But again, you can still use this with other types of data that that you might have, especially if you have data in a large scale. So once you have downloaded it, you just need to extract the data. So I'll do that in my downloads. You might not be seeing what's happening. So I'll just extract it and then upload. Let me just extract mine, which you can also do in your case. And then once you do that, you need to click on the far left. So on the far left of your screen, you just need to upload those files over here. So you can click on upload to session storage, then select all the files that you need, that you have extracted. And all those files should load on the far left, which you can be able to see that that's what we are loading. So that's what you just need to do in order to quickly get set up. And then once you do that, we can start with the first example. So we can load data from a CSV file or even from just different other files using some of the functions provided by Vaex. And in our case, we are going to be loading just some simple data file from a CSV dataset called sales. And we are going to use the from CSV function. And we will load it into a DF, or into a Vaex data frame. That just works more like what we would work with when we are working with a pandas data frame. So a Vaex data frame is just a data structure, tabular data structure that allows us to be able to perform data processing techniques, so to the data at hand. So if I load this and I preview, I can preview the first few rows. These are the head function here would preview 10 records instead of 5 in this situation. So here we have a data frame that contains data with now our data. So yeah, pause the video and then work on the challenge. In some other situations, if we have this data set or if we have a data set in mind, we might also want to load all the column names. If of course we have a lot of column names and we want to work with them, we can use the get column names function to be able to load now all those column names in a list. As you can see here, we get all of them. Pause the video, then work on the challenge. In some other situations, we might want to explore the data types before we perform any data pre-processing techniques. And we can use the dtypes attribute or dtypes property. We apply it to the Vaex data frame once we have loaded our data set, and then we can preview the output, and you can see this is now what we have. You'll notice that the string data or the text data would be assigned a string data type. That's a data type that would be applicable for that type of data when it comes to Vaex. I mean, pandas usually have this as object. All right, pause the video and then work on the challenges. In some other situations, we might want to perform some operations, more specifically, maybe aggregate functions. So we can load our data and then we can apply just the aggregate function that we want. So in our case here, we can apply the sum function to the total price column to be able to get the total sales for that column, or the total sales generally. The same case for total price, you can do the mean and get average sales. The same case for mean and max as well. And you can print out the calculated statistics information. Okay, pause the video and then work on the challenge. In some other situations, you might want to just select columns that, specific columns that we might want, which might be helpful in generally helping us answer some research questions if we do not need the entire data set. So if we had this data frame that we have here and only wanted to work with just a few column names, or not column names, but a few columns, then we can use, can specify the columns, and then we just pass it to df, or this square bracket or the brackets accessor, and then we just display the few records, and this is slightly similar to the way we would do when it comes to pandas as well. All right, filtering records. So in some other situations, we might want to filter for records based on multiple conditions. So if we have this data set and which contains sales data and wanted to get the records that have total price maybe greater than 1,000 and sales region to be east. So sales region on this one would be east. So if wanted records to have those two particular aspects, so we would just define the conditions as we would when it comes to just Boolean indexing. But here we are just defining the first condition, then we define the second condition, and we combine them using the ampersand operator. And yeah, and that's it. So we are able to retrieve the record that we want. All right. In some other situations, we might want to add another column. So create some new data based on existing data. So if we have this data set that contains sales data, we might want to, for example, calculate. Maybe total revenue, it would be our new column, which should be as a result of quantity times price. Yeah, so we can be able to calculate now total revenue column, which is a new column, using this approach where we take the price and quantity columns, multiply them together and equal them to the new column name that we have there. And we can preview the new data frame, which you can see at the far right, we have total data frame, total revenue. Moving on, in some situations, we might want to apply a custom function in the process of creating maybe some new column names. So for example, if we have this data set again that contains sales data, we can just preview the data types to just be sure about the operations that we want to apply, because sometimes if we want to apply maybe arithmetic operations, on the data, we would need to ensure that we have numerical data types, either int or float. And then we define our function. So in our case, we want to create a new column called profit margin that would be as a result of this custom function. And the custom function would take revenue and cost, and it would now perform that operation that would lead to the profit margin. So we can define the new column name, then df, then we use the apply function, then we say calculate profit margin, then we set the arguments for this particular, the columns for the argument for this particular function. So we have total price, which would be what we will give as the revenue, which again, I would say the best thing would have been actually to use the new column over here, but for now we're just going to use that we have. Then we can say costs would be now what would be as a result of total price times 1 minus the discount. So that's what we would be given to the function, custom function, and we would apply that to, we would have that, and that would give us now the profit margin, and we can display that. On the far right, you can see the profit margin. All right, aggregating data. In some other situations, we might want to create a pivot table, a summary table based off a bigger table. So in this case, if we want maybe to create a smaller table, a pivot table that has IT departments and the mean of the salaries for those IT departments, we can use the group by function and specify the column we want to group by the data, and that's the department, and we specify the aggregate function and the column that we want to apply it to. So department, then that's the salary column. We want to get the mean values for the salary column, and we just access the aggregate function using vaex.ag and mean. All right, let's display that. All right, lastly, we can export the data that we have to various formats here. We're just exporting maybe to just an easy example, CSV, but again, the other functions, if we look into a documentation, that we can be able to export the data to. So here we're just going to read this data, and then we can drop the data, the columns that we don't want. This is also another way. Instead of selecting, we can just decide to drop the columns that we don't want in the data frame, and then store them in HR data, and then apply the export CSV function to export it to a CSV. And if you check on the left-hand side, if you click on refresh, you should see pre-processed data at the very bottom, which you can see there. All right, so that's it. So that's it with regards to this learning experience. I hope you were able to get some value from this this particular resource, and are able to say that if it comes that you need to efficiently work with data when it comes to Python, especially data that's in quite large, then you are well equipped to do that. So yeah, if you did love this, if you did like this learning experience, be sure to give it a thumbs up. It tells us that we're doing a good job. And if you'd want to be informed when we post such future learning resources, be sure to subscribe. And all the best in your learning journey. Bye-bye.